Okay, we're on exam number 2, which is actually the third exam of the semester. So we've taken exam number 1, the midterm, and now this is exam number 2. All right, let's look at the first question. The first question says, write the vector v in terms of I and j, where the length of the vector v is equal to 8, and the direction is 30 degrees. What I would do is I kind of draw the picture of it. Let me get back to the back plan, by the way. I draw a picture of the vector. And what about the vector? It's got an angle of 30 degrees. All right, so I'm going to say in standard position, this looks roughly 30 degrees to me. Right, the length of this vector, they say it's length 8. All right, now what's nice about this, I recognize it's a very simple triangle. And what do you get over there? The sides would be 4 root 3. This is 30, 60, 90, by the way. And this would be 4. All right, so I write the vector down now. The vector v is equal to, well, the I is going to be 4 root 3 vector I plus the vector next to the vector j is going to be 4 vector j. Now, of course, I'm going to look in the answer key for the answer, and I'm hoping to see that. And do I see that? I believe I see that in C. Let me just make sure of that. 4 root 3i. Yep. Let's go to the next question. Next question, again, the 3 Q's. Again, you may not enjoy these numbers, but they're really not bad to visualize. Let's put this down. So I go over 2 up 2. This is real. This imaginary. And that looks like this over here. So it's got a reference angle of 45 degrees, which we call the argument. So theta is 45 degrees. And the r, well, the r I'm just going to, square the 2. It's 4. Square the 2, it's 4. 4 plus 4 is 8. So the r is root 8, right? So what do you get over here? Z is equal to the root of 8. And then it's going to be cosine of 45 degrees plus I sine of 45 degrees. And as many as you know, if you're attending classroom, that I like to write this as CIS. All right, that part's done. Now what I got to do is I got the roots down now. And this is the Moss theorem. And I really have to look at this over here. 45 degrees plus 360 degree K over 3, which is 15 degrees plus 120 degrees K. All right, I'm going to write the roots down now. And we've been using the W notation in class, by the way. The first root, or the 0th root. It's going to be the cube root. These are principal roots of the R. What's the R? Well, the R is just root 8. Now, I'm going to look nasty to you, but that's what it is. And that's going to be CIS. Well, I'm going to take K to be 0, so that's 15 degrees. W1, that's the cube root of the root of 8. It's a nasty number. CIS. I'm taking K to be 1 now. Now, if K is 1, I'm going to get 120 plus 15, which is 135. Let's do W2, the cube root of 8, CIS. And then what I do there, it's 2 times 120, 240, 250, I'm sorry, 240, 255. Now, if you kept going and you add another 120 onto that, you're going to be back at 15 degrees. This is a sufficient answer. As I said in classroom, if you don't want to do the arithmetic, do not do the arithmetic. But these numbers really can be done. Like, for example, 15 is a half-angle formula. 135 so I get to 45, and 255. I guess you could figure that one out too. But again, an exam, just go to the next question. You don't have to do the arithmetic. Let's put this one down. It says write the complex number in trigonometric form. Well, this doesn't look bad. I think I can handle that. And what it's going to be a real part, and this is the imaginary part. And go over 9 up 9. If you do that, 9, 9. Well, I know the argument's 45 degrees now. Again, we're trying to use easy numbers. What's the R going to be? Well, I have to square the 9, which is 81. Square the 9, 81. So it's 2 times 81, but I'm taking the root of that. And what's it going to give me? 9 root 2s. All right? So let's write the complex number down. And the complex number is still going to be Z. What's the R? It's 9 root 2. I do prefer to write down CIS, and that's going to be 45 degrees. Now, what does that mean to me? Z is equal to 9 root 2 cosine of 45 degrees plus I sine of 45 degrees. Let's look in the key and see if we see that. And I got to look at it. And this is number 23, so let's take a look. Do I see the 9? Oh, they're all 9 root 2s, so that's not so bad. Then I'm looking for the 45, 45, and I see that right over here. And we're done. Next question. Next question says find the exact angle between the vectors. So cosine of theta is going to be u dot v over the length of u, length of v. All right? So arithmetic time. U dot v, 6 times minus 3 is minus 18. 7 times 1 is 7. That's going to be minus 11. Let's do the bottom now. That's a square root. That's going to be 36. I'll put this on the side for you. And 7's 49. And what does that give you? 85. All right? 85. And then let's do the next one. Well, that's a little bit easier. It's 9 plus 1, which is 10. So that's going to be root 850. So theta is going to be the arc cosine of minus 11 over 850, the root of it. Now, by the way, this is an answer. You can leave that. It's an exact answer. If you want to do some arithmetic, you can. I'm going to say the arithmetic's not that bad over here. And I'll point out what I mean by that. 850 is certainly divisible by 25. All right? So they're multiple of 25. You might not know what the multiple it is, but 3 would give you 75. And then you get 10, 100, 4. So 850 is really the same thing as, let's take a look, 25 times 34. And the square root of 25 is 5. So 5 root 34. Again, if you want to do that, that's fine. I'm not going to say it's worth extra, but if you want to do that, you can. So the two acceptable answers are the ones we just listed. So let's do the next one. And the next one, another multiple choice, by the way. And they want to do convert this rectangular point, which means that this is the x and this is the y, and they want me to express it in polar form. So x squared plus y squared is equal to r squared. And what do you get there? You get 0 plus 4 is equal to r squared, which means r could be plus or minus 2. But I notice here they want the r to be positive, so I'm going to say the r has to be 2. All right? The next thing I'll do is I want to figure out the angle. And the way I do that is I draw a picture. All right? And these are polar coordinates. And what do? I'm looking at the Cartesian, which is x and y. I'm trying to find an angle now. And how do I do that? Well, the x is 0, but the y is minus 2. It's over here. What's the angle going to be? Well, the theta is going to be 270 degrees. How do we report the polar form? R theta. So it's 2, 270 degrees. If you were using radians, it's 2, and this would be 3 pi over 2. Right? What am I looking for? The answer in the k, and I notice it right over here. And we're done with that. Let's go to the next one. This one is to find a unit vector in the same direction as v. So what you do is it's 1 over the length of v. That's a scalar multiple now. Times v. Let's write this down. 1 over the length. The length, let's take a look at that. 25, because minus 5 squared is 25. And when you square that, negative 12, you get 144. And what's v? V is minus 5, minus 12. Right now, the arithmetic doesn't look that bad, by the way. 25, 144 is 169, and the square root of 169 is 13. So it's going to be 1/13 times minus 5 minus 12. Now, by the way, if you want to put that answer down, you can. I'm going to write a little differently as minus 5/13, comma, minus 12/13. Excuse me. Have you got the next question? The next question, I have to add two vectors together, u and v. So I'll add that together, and then after I do that, I got to subtract the vectors, and then I got to take a dot product. And the two vectors are given right here, and I'll go through that. So u plus v is 4 plus 1, which is 5, and then 1 minus 7, which is minus 6. Now u minus v, that's 4 minus 1, which is 3, and then 1 minus minus 7 is going to be 8. Dot product, 5 times 3 is 15, and minus 6 times 8 is minus 48. All right, so 15 minus 48. Again, I'm looking at the answer. I don't see that answer over there. I guess they want me to do the arithmetic over there, so it looks like minus 33. Let me just check that. 33 and 15, yeah, minus 33. Do I see that answer? I do. It's choice A. Let's go to the next one. The next one is a visual problem for me. And the reason why I'm looking at a survey, what he's doing, he wants to find the distance to 2 points A and B. I'm not going to say my pictures are good, but they're good enough for me. And then they say a surveyor chooses a point C that's 375 yards from A and 530 yards from B. So I'm going to make maybe something like this over here. And again, I'm not saying I'm doing a terribly accurate picture, but they say this angle over here is 60 degrees. All right. Now, I'm going to call this point C, and they want to know this distance over here, which I'm going to call letter C. This side over here is side A. It's opposite angle A. And this side over here is side B, which is opposite the angle B. Now, the distance between B and C, I have to read that again. It says over here, determine the distance A to B. Surveyor chooses a point C that's 375 yards from A. I'll put this over here. They're in yards, by the way. And from, maybe I made a mistake over here. Surveyor chooses a point C that's 375 yards from A and 530 yards from B. I'll put this over here. And that's yards, by the way. I'm going to say clearly a case of law of cosines. So law of cosines. Now, exact values. I'm not going to use a calculator unless I can, maybe do some simple calculations. But C squared is going to equal, let's see, A squared. That's 530 squared. Plus the B squared, 375 squared. Minus 2 times 530 times 375. And then I'm going to get the cosine of 60 degrees. Right? I want to remind you, 60 degrees, you should know it. Right? 60 degrees looks like that kind of triangle over there. 1, 2, root 3. The cosine is just a half. So C squared is going to be 530 squared plus 375 squared. Now 2 and a half would just give me 1. So I'm left off with something pretty simple. 530 times 375. Now, I don't want to rewrite it. I'm just going to simply say C is a positive number. So what I'm going to do is I'm going to just simply put down C and then put the root symbol here. And then write the unit down. And the unit's yards. I'll just put YDS down. Put a little box in this over here. And that's the exact answer. Now, granted, someone says, I want to do the computation. Well, on example, I wouldn't do the computation. I'd leave it there. So again, 530 squared, 375 squared, minus 375 times 530. I did okay. Let's go to the next one. And we get pretty close to the end of the exam. And this one has to do with a sum formula. Now, I'm looking at these things over here, and I got to realize these are angles over here. So I'm just going to call this A and call this one B over here. Now, what I notice about the arctangent, the ratio is 4/3. So this is B. I know the arctangent, if it has a ratio of 4/3, it's got to be an acute angle. And I'm going to put this over here. I'm not going to say it's the best picture, but it's enough for me, by the way. And I'm looking at this thing on, this would be 4, this would be 3. Again, reason for that, tangent is 4/3 of A, because the arctangent of 4/3 is some angle A. And this over here is 5. It's a 3, 4, 5 right triangle. Got that covered. The next one, I'll write this one down. Again, I'm going to do my same hokey triangle, the right triangles. And that's the arc sine 3/5. I know that's going to also be an acute angle. It's between 0 and 90. And what do you get over there? That would be 3. This would be 5. And lo and behold, it's still a 3, 4, 5 right triangle. So what do I put over here? Let's write this down. It's going to be the cosine of A, cosine of B, plus the sine of A, the sine of B. Now, do I know the cosine of A? I do. I'm looking at it. It's 3/5. Do I know the cosine of B? It's 4/5. Plus, do I know the sine of A? I'm kind of looking at that. That's 4/5. And do I know the sine of B? That's 3/5. All right, what do you get there? 12 over 25 plus 12 over 25, which is 24 over 25. All right, getting pretty close to the end. And this one, convert this polar equation into rectangular form. I would clear the fraction first, and I get R plus R sine theta is equal to 1. Well, I immediately notice I got something over here. R sine theta is just Y, and that equals 1. Now, I got mixed language over here. I'm using the polar form and the Cartesian form, and what I got to do is I got to get them separated. So it's 1 minus y. I would square both sides. I would get r squared, and then I get 1 minus 2y plus y squared. And you may wonder why I square both sides, because r is something that I know about if it's in the r squared form. And that's going to be x squared plus y squared. Now, if that's your idea of writing the equation down, that's a good answer. You did convert it. But I want to put it in a better form. And the way I'm going to do that is just subtract y squared from both sides. And you get x squared equals 1 minus 2y, which is an acceptable answer. I'm also going to solve for y. And what do you get? 2y would be 1 minus x squared. And that means y equals 1 minus x squared. Whoops. Sorry about that. Over 2. Now again, someone says, what's the best form? I'm not going to say one form is better than the other, but I think the last form is probably the most recognizable to me. It's a parabola. It faces downward, by the way. And we're done with the exam. Thank you for paying attention.